Hey everyone, this is the Math Nexus, and today we are going to start with exercise 2.6. Um, Again, if you're just jumping in right here, please do not watch my previous lectures and come on so that your concepts may be more clear. So just as a revision, in the previous exercise, we discussed when we have 2 points of intersection, or we can say when we are cutting our parabola at 2 points, that's the same thing. We say that our discriminant, which is b squared minus 4ac, it's going to be greater than 0 at this situation. Okay. Then the second thing we discussed was that in if we have only 1 point of intersection, that would mean that it would be b squared minus 4ac, meaning the discriminant should be equals to 0. And another thing I want to add on in this is that when we have 1 point of intersection, that it would mean that that line would actually be acting as a tangent to the curve. So what's the tangent? Basically, we all know that we take the tangent when taking out, we use the tangent method when taking out the gradient. We are not going to go in detail about that, but basically we know what a tangent is. A tangent is a line which only touches 1 point of the curve. I know it's not exact here. So it's only going to touch 1 point of the curve, and that's a tangent. So again, we can say that when our discriminant equals to 0, we have a tangent to our curve. In other words, we can say that. Then there's another situation which says that the curve is not at all intersecting with our given line. Okay. And when that situation comes, we say that our discriminant b squared minus 4ac, it is going to be lesser than 0. So that's a basic revision. And another learning fact that when a line is touching only 1 point of a curve, it's going to be a tangent. We all know that, but still, I wanted to tell you this because it's going to be really helpful as we are going to solve exercise 2.6. Okay, so exercise 2.6, that's all we need to know as a backhand. We're going to solve it. Is mostly like the previous exercise, not big changes here. So for question number 1, we have find the values of k for which y is equals to kx plus 1 is a tangent to the curve y is equals to 2x squared plus x plus 3. So what they've given us is two equations. One is the equation of a straight line, y is equals to kx plus 1, and the other one is a quadratic equation which allows us to form a parabola. Okay, so it's really simple. What they've told us is to find the values of k for which these two curves and the line is intersecting. And another thing they've told us is that this line is a tangent to the curve. And again, when some line is a tangent to the curve, we know that it's only touching 1 point of the curve. And when it's touching 1 point of the curve, we know that its discriminant would be equals to 0. So first of all, we have to solve this equation now. How we'll solve this? Just as both of these points are intersecting, we can say that y and x values would be same at that intersection points. So what we are going to do is substitute both of the equations. We are going to say kx plus 1 is equals to 2x squared plus x plus 3. Okay. Okay, now what we're going to do is just directly solve this up. So it's going to be 2x squared plus x minus kx plus 3 minus 1 is going to be plus 2 is equals to 0. Okay, now just simplify it a bit. 2x squared plus we are going to take x as the common. 1 minus k plus 2 is equals to 0. Now we have our basic formula for the quadratic equation, ax squared plus bx plus c. And now in order to form the discriminant, we need to find out the coefficient of x squared, the coefficient of x, and the coefficient of c. So what we're going to say is A is equals to 2, B is equals to 1 minus K, and C is equals to positive 2. Now we are going to go on to just put this into a discriminant equation. B squared, 1 minus K whole squared, minus 4 multiplied by A, which is 2, multiplied by C, which is 2 again. And what they've told us, it is the tangent to the curve, meaning only one point of the line and the curve is intersecting. So we can say that this point is equals to 0 because the discriminant is equals to 0 when only one intersection point is there. So now what we're going to do is just really quickly simplify this. A minus B whole squared is equals to A squared minus 2 multiplied by A multiplied by B plus B squared minus 4 to the 8, 8 to the 16 is equals to 0. Simplify this. K squared minus 2K minus 16 plus 1 is going to be minus 15 is equals to 0. Going to further solve this. As this is the first question, I'm going to solve the equation by finding out the factors. Otherwise, I'm going to use the calculator from next time. So 15, we take the factors 5 and 3. So we have K squared minus 5K plus 3K minus 15 is equals to 0. K as the common, K minus 5 plus 3 as the common here, K minus 5 is equals to 0. So we have K is equals to 3 or K is equals to negative 5. In fact, my bad. K is equals to positive 5 or K is equals to negative 3. So these are the two values of K for which our requirement is satisfied as per the question. So that's it for question number 1. Let's proceed on to question 2. Okay, proceeding on to question number 2, we again have a similar question. What they've told us that find the value of K for which the x-axis is a tangent to the curve y is equals to this, this, and this. So again, we have a quadratic equation y is equals to x squared plus 3 minus k x minus 4k plus 3 as a whole. So what I prefer to do first of all is turn this into the general formula of the quadratic equation, which is ax squared plus bx plus c. And as you can see, it's not following general formula ax squared plus 3 minus kx, but it's a negative here. We turn this negative into a positive, and how do we do that? So y is equals to x squared plus 3 minus kx plus minus 4k minus 3. Now, the second thing they have told us that there's an intersection between these points when with the x-axis. Now, if you would visualize this graph, it would be something like this. This is our x-axis, and a parabola would come up and touch the x-axis at this point. So we can say that when y is equals to 0, this intersection at the x-axis, or you can say x-axis acts as a tangent. So that's happening when y is actually equals to 0. So we can say that x squared plus 3 minus k x plus negative 4k minus 3 is equals to 0, and that's our equation. So no need to further simplify it. However, what we are going to do is now use a discriminant to solve this up. So this equation is equals to 0 as a whole. Now, taking the equation of discriminant b squared minus 4ac. So for now, a is equals to 1, b is equals to 3 minus k as a whole, and c is equals to negative 4k minus 3. Okay, if I'm not wrong, yes. So what we're going to do next is b squared 3 minus k whole squared is equals to a squared, which is 9 minus 2 multiplied by a multiplied by b plus b squared. So this will be equal to k squared minus 6k plus 9. Now, putting this into the equation of the discriminant b squared minus 4ac. So we already know b squared is k squared minus 6k plus 9 minus 4 multiplied by a, which is 1 itself, and c, which is negative 4k minus 3. Further simplify this, we are going to get k squared minus 6k plus 9 minus, positive 4 is 16k plus 4 3 is 12. Simplify this, k squared 16 minus 6 is equals to positive 10k. 9 plus 12 is equals to, what's 9 plus 12? 21. And what we did not decide right now is what it should be equals to. So x-axis is a tangent, that means only one intersection is happening. So when there's one intersection, the discriminant is equals to 0 itself. So we can say this whole equation is equals to 0. Same for this and same for this. Now I'm going to use my calculator to solve this quadratic equation. So 1, positive 10 and positive 21. So we are going to get two values for k, which is k is equal to negative 3 or k is equal to negative 7. And that's it for question number 2. Okay, for question number 3, we have find the values of the constant c for which the line y is equal to x plus c is a tangent to this curve. So again, a tangent has only one intersection point with the curve. So we can say that the discriminant, which is b squared minus 4ac, is going to be equals to 0 for this question. For now, what we are going to do is substitute both of these equations into each other because the x and y will be same at the intersection point. So x plus c is equal to 3x plus 2 upon x. Now, if we simplify this, we are going to get x plus c is equal to 3x squared plus 2 upon x. X squared plus cx is equal to 3x squared plus 2. Again, 3x squared minus x squared is equal to 2x squared minus cx plus 2 is equal to 0 to x squared. So again, what will be the a, b, and c? A is equal to 2, b is equal to negative c, and the constant c is equal to 2. Input this into the equation. So b squared is equal to negative c squared is c squared minus 4ac, 4 multiplied by 2 multiplied by 2 again. And this should be equal to 0 because it's a tangent, and a tangent intersects at only one point. Next, we are going to say that c squared minus 4 to the 8, 8 to the 16 is equal to 0. C squared is equal to positive 16, and c is equal to positive or negative 4. Either of these two answers. It's better to write positive, negative 4. As you can see, they've also asked the values. So again, the two values are positive and negative 4. And that's basically it for question number 3. Proceeding on to question number 4. For question number 4, we have two equation again. What they're telling us that we have to find the values of the constant k for which these two the line is cutting the curve at two distinct points. Again, when we are cutting something at two distinct points, our discriminant b squared minus 4ac would be greater than 0. So keep that in mind when solving this question. So again, just substitute 3x plus 1 is equals to x squared plus kx plus 2, because at the intersection points, the coordinates would be the same for both the line and the curve. So 3x plus 1 is equals to x squared plus kx plus 2. Simplify this, x squared plus kx minus 3x is equal to 2 minus 1, which is 2 minus 1 is positive 1, is equals to 0. Okay, so simplify this. Now I'm going to factorize the coefficient of x. So x squared plus x as the common k minus 3 plus 1 is equal to 0. Again, identify the a, which is 1, b, which is k minus 3, and c, which is 1 itself. Now what we're going to do is k minus 3 whole squared minus 4 multiplied by a, which is 1, multiplied by c, which is 1 again. And we are going to say that this is greater than 0 because it's cutting at two distinct points. So k minus 3 whole squared would be a squared, which is k squared, minus 2 multiplied by a multiplied by b plus b squared, which is 9. Minus 4 is greater than 0. So k squared minus 6k plus 9 minus 4 is 5 is greater than 0. Again, I'm going to use my calculator for this. It's a really basic one, quadratic equation. So I'm going to use a calculator. 1 minus 6 and positive 5. So we have two values for k. K is either equals to 5 or it's equals to 1. And again, as we discussed in the previous lectures, that when we have an inequality, when we have a quadratic equation with an inequality, we use a mini graph to find out the answer. So what they asked us for the values for this quadratic equation were the values which were greater than 0. So between the point 1 and 5, there's a parabola which is going down. And what they've asked us the values which are greater than 0 for this parabola. So again, if you do not understand what I'm going to do now, watch my previous lectures. It's really important to first clarify the most basic concepts. So what are the values for this parabola which are greater than 0? Well, the values which are below 1 are greater than 0 and the values which are above 5 are greater than 0. So we can say that k is actually lesser than 1, but k is greater than 5. And that's the answer for question number 4, for which our conditions are going to be satisfied. So that's it. Proceeding on to question number 5. Let me just clear some space here. Okay. So for question 5, we have the line y is equal to 2x plus k is a tangent to the curve x squared plus 2xy plus 20 is equal to 0. So first of all, they've asked us to find the possible values of k. Again, it's really simple. They've told us this straight line is a tangent to the curve. So we can say that when it's a tangent, only one intersection point is taking place. So b squared minus 4ac is equal to 0 in this question. So first of all, we have to substitute both of the y values. So x squared plus 2x. And instead of y, we are going to write out the equation of the straight line. So 2x plus k plus 20 is equals to 0. Simplify this, x squared plus 2x multiplied by 2x is 4x squared plus 2xk plus 20 is equals to 0. 5x squared plus 2xk plus 20 is equals to 0. Again, what we have as the ABC, the coefficient of x squared is 5, so a is equals to 5. Coefficient of x is equals to 2k. So b is equals to 2k and the constant is 20. Really simple till here. What we are going to do next is substitute this into the discriminant b squared, which is 4k squared. 2k uh, 2k squared is equals to 4k squared plus, by the way, I mean 2k as a whole squared. So plus minus 4 multiplied by a multiplied by c is equals to 0. Again, simplify this, 4k squared minus 5 4 20 20 20 is 400 is equals to 0. So 4k squared k squared in fact is equals to positive 400 divided by 4. So k squared is equals to under root 100 and k squared is itself equals to 100 and k is equals to under root 100, which would give us two values, plus and negative 10, positive or negative 10. Again, I am emphasizing on the fact when you open an under root for an answer, it's better if you write two values, positive or negative 10, because an under root could be made up of anything. 100 could be made up of multiplying negative 10 by negative 10, as that would get positive 100. And 100 could also be made by multiplying 10 by 10. So again, take both possibilities in consideration, um, and that would be your answer. And another thing is, if you would have written positive 10 as a single thing, your answer wouldn't be correct. Okay, the examiner would have marked 0 for this because there's no 0.5 for this. The only grading you would get would be for the working, but the thing is, your answer would be in the end be incorrect because you have not given the second possibility, which is negative 10. So your answer should be complete, as they've also, again, what they've asked in the question, possible values of k, possible values. They've told us, already hinted that there are two values. So again, keep that in mind. Okay, for part B, what they've asked us is, for each of these values of k we have found out, which are positive 10 and negative 10, what we have to do is um, find the coordinates of the point of contact with the tangent. Meaning they're just asking us the intersection coordinates for both of these values of k. So first of all, we are going to say for when, in fact, when k is equals to positive 10, we are going to use up this equation 5x squared plus 2xk plus 20 here. 5x squared plus 2xk plus 20. And the reason why I'm using this equation is because I've already substituted both of these equations into each other, and that's a refined form of that. So 5x squared plus 2x plus 20 is equal to 0. We have this, sorry, 2xk is plus 20 is equal to 0. So 5x squared plus 20x plus 20 is equal to 0. We have substituted the value of k as 10 here. So it's a really basic equation. So I'm going to solve it with my calculator. In fact, what I'm going to do is solve it right here. So 20 multiplied by 5 is 100. Take the factors of 100. So 5 2s are 10, 5 0 is 0, 5 4s are 20, 2 2s are 4, and 2 1s are 2. Make up 20 from these factors. 5 5 are 25, 2 2s are 4. Wait, 5 2s are 10, 5 2s are 10. Yes. So 5x squared plus 10x plus 10x plus 20 is equals to 0. 5 as the common. Wait a second. We could, well, if you have done this, it's also correct. But an easier method would be to first of all take the common. So 5 as the common, x squared plus 4x plus 4x. Again, I'm repeating, you could have continued with that, but so that you could have some simplification methods. I did this again. So x squared plus 4x is equal to 0, because when 5 divides here, it's essentially going to become 0 again. So again, what's the factor of 4? 2 and 2. So x squared plus 2x plus 2x plus 4x, plus 4 in fact. My bad, I copied it down incorrect. So 2x plus 2x plus 4 is equal to 0. X as the common, x plus 2 plus 2 as the common, x plus 2 again is equal to 0. Again, so both of our values is going to be same. X is equal to negative 2. So when x is equal to negative 2, we have to find out the y value. So when x equals to negative 2, y is equals to 2x plus k. So y is equal to negative 2 multiplied by sorry, y is equal to 2 multiplied by negative 2 plus 10. So it's going to be 2 to the 4. Negative 4 plus 10 is equals to positive 6. So our answer will be negative 2 and positive 6 here. However, let me just erase for some space. For the point when k is equal to negative 10, we are going to get different values. When k is equal to negative 10, I'm going to solve this equation again. 5x squared plus 20, 2xk plus 20 is equal to 0. Multiply it, 5x squared minus 20x plus 20 is equal to 0. Take the common of 5x squared minus 4x plus 4 is equal to 0. So we are going to get x squared minus 2x plus 4 is equal to 0 after the middle term break. So x as the common, x minus 2 here, minus 2 as the common here, x minus 2 is equal to 0. So again, our answer is going to be x plus 2, sorry, x is equal to positive 2 when k is equal to negative 10. And what about the y value when x is equal to positive 2? Y is equals to 2 multiplied by 2 plus 10. Sorry, plus minus 10. My bad. Because we are taking when k is equal to negative 10 here. So y is equal to 4 minus 10, which would become negative 6. So our value when k is equal to negative 10 would be positive 2 and negative 6. So our two coordinates in the end are answer is equals to negative 2 and positive 6 and positive 2 and negative 6. That's our answer for question number 5, part B. And as it proceeding on to question number 6, we have find a set of values of k for which the line y is equals to k minus x cuts the curve y is equals to x squared minus 7x plus 4 in two distinct points. Again, it's better if you underline the main points. So we have the two equation here, and two distinct point is also one of the main highlights. So when there are two distinct points, we can say the discriminant b squared minus 4ac is going to be greater than 0. And we are going to keep this in mind when solving the question. Substituting both of these equations into each other, because again, the intersection points are going to be same for them when they're intersecting. So k minus x is equals to x squared minus 7x plus 4. Simplify this up, x squared minus 7x plus x plus 4 minus k is equals to 0. Simplified version would be x squared minus 6x plus 4 minus k is equals to 0. Again, what would be the coefficient of x squared? 1. The coefficient of x is negative 6, and the coefficient of c is 4 minus k as a whole, because the constant is something which is not a coefficient of anything itself. It's independent. So b squared would be 36 minus 4 multiplied by a multiplied by 4 minus k, and this is going to be greater than 0. So 36 minus 4 multiplied by 4 is 16 plus 4 multiplied by k is 4k is greater than 0. What is going to happen next is 36 minus 16 is going to give me 20 plus 4k is greater than 0. So 4k is greater than negative 20 and k is greater than negative 5. So that's our answer. K is greater than negative 5 is the answer for question number 6. As you can see, this one was fairly simple. Let me raise this one up so that I can just solve question 7 easily. Okay. For question number 7, what they've told us, again, they've told us y is equals to kx minus 10, and the quadratic formula for the parabola x squared plus y squared is equals to 10x. So, and what they've told us that these two lines and curve is meeting. They've only told us one thing, they're meeting up. Okay, they've not told us it's a tangent, they've not told us it has no intersections, they've not told us that it's intersection at 2 points. They've only told us the fact that they are meeting each other. Okay, so when does a line and parabola meet? Well, there are two situations in which they meet. As we know that at 1, it's a tangent, meaning there's only one intersection. And the other situation is that they're meeting at 2 points, meaning there are two intersections. And that's what we are saying. When there's one intersection, our discriminant is equals to 0. And when there are two intersections, b squared minus 4ac, our discriminant is greater than 0. However, if the question has only told us that it's meeting the curve, we do not know it's either one intersection or two intersection. We only know that it's meeting. We will say that the discriminant would be equals to, greater than, and equals to 0, because it may be equals to 0, which would give us one intersection point, or it may be greater than 0, which would give us two intersection points. So in that end, discriminant for this question would be b squared minus 4ac is greater than or equals to 0. So keep this in mind. Our discriminant would be something like this. Second step. Now we have to substitute both of the equations into themselves so that we can solve this up. And a disclaimer before we start, this one is easy, but it's really, lengthy, you can say. Some of you may confuse because there's a lot of multiplication and something like that here. So to solve it, kx minus 10 is our y value. We are going to input this into our equation, x squared plus y squared is equal to 10x. So x squared plus kx minus 10 whole squared is equals to 10x. We can say that. Okay. What's going to happen next is we are going to open this up. X squared plus a squared kx whole squared would be k squared x squared minus 2 multiplied by a, meaning kx multiplied by b, which is 10, plus b squared, which is 100, is equals to 10 multiplied by x. Okay. Simplify this up. Take the coefficient of x squared as a common. X squared 1 plus k squared minus 2 multiplied by 10 is negative 20. Negative 20 multiplied by k is negative 20kx plus 100. In fact, before plus 100, I'm going to add minus 10x as it comes from the other side. Plus 100 is equal to 0. Again, simplify this. X squared 1 plus k squared minus, we're going to take positive x as the common. I prefer if you take positive as the common. Minus 20k minus 10 plus 100 is equal to 0. Okay, so that's it. That's how we would simplify this and find out the coefficient of x and x squared and obviously the constant. So again, following the general formula, the coefficient of x squared is 1 plus k squared as a whole. And the coefficient of x is minus 20k minus 10 as a whole. And the constant is 100. Now we need to solve this up real quick. And now it's going to get a little bit of trickiness. So b squared negative 20k minus 10 whole squared minus 4 multiplied by 1 plus k squared multiplied by 100. If we would open this up, negative 20 squared would be positive 400 k squared, because what we are doing is negative 20 multiplied by negative 20 is 400 multiplied by k multiplied by k. So k squared. And by the way, please do not ask me the question, why haven't we just taken this as a whole squared and opened it up? I mean, it's really simple. These two are multiplying. We open up the brackets, use the quadratic formulas when it's there's some addition or subtraction. So a squared would be 400k squared minus 2 multiplied by a, which is negative 20k, multiplied by b, which is positive 10, plus b squared, which is 100. Minus, we simplify this along with the other equation, minus 4 minus 4k squared. In fact, my bad. We multiply negative 4 by 100 first. That would give us negative 400. So negative 400 multiplied by 1 is negative 400 plus negative 400 multiplied by k squared would be negative 400 k squared. Is now we can say that this whole is greater than equals to 0. I know it's a bit confusing right now, but again, we discussed earlier b squared minus 4ac would be greater than or equals to 0 because we would have either one intersection point or two intersection point. We do not know for now. So again, simplify this up. 400k squared would be cut down by 400k squared. Negative 2 multiplied by 10 is negative 20. Negative 20 multiplied by negative 20 is equals to positive 400k. Cut this down. We have already written this. Plus 100 minus 400 is minus 300 is greater than equals to 0. Simplify this up. What I prefer to do is take 100 as the common first. 4k minus 3 is greater than equals to 0. When this 100 goes on the other side, it's going to divide by 0, and essentially it's going to become 0 again. So 4k is greater than equals to positive 3. K is greater than equals to 3 upon 4. Okay. And that's our answer. We can also write k is greater than equals to 0.75. And that's it. This is it for question number 7. I know it's not lengthy, but it's kind of confusing because there's a lot of multiplication. There's huge values in this. And sometimes student gets confused when dealing with larger values. But still, it's easy. For question number 8, we have find the set of values of m for which y is equals to mx minus 5 does not meet the curve y is equals to x squared minus 5x plus 4. So when they meet does not meet, there's only one situation when the curve is not going to meet the line. And that's when the discriminant b squared minus 4ac is lesser than 0. So that's what we will be using in our equation. First of all, we substitute both of these values because, again, I've been repeating this over the whole exercise because I need your concepts to be clear. We are substituting both of these values because at the point of intersection, the coordinates of the both points will be same. For example, we have this graph and we have this line going up here and this. So these 2 points are the intersection points. And the coordinates of these points are going to stay the same, whether we take it from the equation of the straight line or whether we take this point from the equation of the curve. It's going to be the straight point. It's going to have the same x value and it's going to have the same y value. So please do clarify that concept. So mx minus 5 is equals to x squared minus 5x plus 4. Simplify this up. X squared minus 5x minus mx plus 4 plus 5 is equal to plus 9 is equal to 0. Simplify this, or you can say factorize this. Minus x as the common, in fact, positive x as the common. Minus 5 minus m plus 9 is equal to 0. So again, what's the coefficient of x squared? A is equal to 1. B is equal to minus 5 minus m as a whole. And the constant is equal to 9. So b squared would be minus 5 minus m whole squared minus 4 multiplied by a multiplied by c, which is 9. And we would say that this whole is lesser than 0. Again, so what's negative 5 squared? A squared is 5 5 is 25 minus b squared, a squared minus 2 multiplied by a, which is negative 5, multiplied by b, which is m, plus b squared, which would be m squared, minus 9 forza is 36, is lesser than 0. By the way, those of you who are confused, why have I taken negative 5 as a whole here and not negative m here? Well, the equation, if we would say the quadratic formula, or you can say the identity, is a minus b whole squared is equals to a squared minus 2ab plus b squared. And basically what happens here is when we take minus b, when the equation is about a minus b whole squared, we take only b in consideration. However, if our equation would be negative a, we would take negative a as a whole in consideration. Okay, it's not going to be is the same as the for the value of b. The value of b, if we compare this into the question, it's the same. So we are going to follow the general rule. However, a and negative 5. So we do not have a rule for negative a. We consider negative a as a. I know it's confusing, but you listen to this 3 to 2 times and you'll uh, you'll start to understand what I mean here. So we take negative a as a whole. However, we take negative b, we only take the b value. I know it may sound confusing, but please try to understand. Okay. And if you don't understand it, still ask me in the comments. I'll try to make another video about that. So 25 minus, in fact, that would become positive 10 m. 25 to 10 m. Positive 10 m plus m squared minus 36 is lesser than 0. Now what we would do is simplify this up. 25 minus 36 would give me minus 11. So m squared plus 10m minus 11 is lesser than 0. Now I'm going to use my calculator for this. So 1m squared plus 10m minus 11. So that would give me two values for m. M is equals to 1 or m is equals to negative 11. Now, again, we have discussed in the previous lectures how to solve these type of questions. So when we have an inequality in a quadratic equation, we have to draw a mini graph and estimate what our answer would be. So negative 11 up till 1. So that's a parabola going like this. And what they've asked us are the values which are lesser than 0. So between negative 11 till 1, we have the values which are lesser than 0 for this graph. So we can say that m is greater than negative 11, but it is lesser than 1. Again, if you don't understand what I'm doing here, please do watch my lectures for, I guess, exercise 2.4. Yes, for exercise 2.4, and you will be clarified about the concept which I've used here. So that's it. Our answer is that m is greater than negative 11, but lesser than positive 1. So that's it for question number 8. What we're going to do is now continue with question number 9. Let me just do this. Question number 9 would be the line y is equals to mx plus 6 is a tangent to the curve y is equals to x squared minus 4x plus 7. So we know now that this line is going up here and being a tangent to the curve, meaning there's one intersection for this. And when there's one intersection, we also know that the discriminant b squared minus 4ac would be equals to 0. So for that same reason, we are going to use the discriminant to be this. So first of all, step 1, substitute both of these values. So mx plus 6 is equal to x squared minus 4x plus 7. X squared minus 4x minus mx plus 7 minus 6 is equals to plus 1 is equals to 0. Factorize this up, x squared minus minus positive x as the common, minus 4 minus m plus 1 is equals to 0. So the coefficient of x squared is equals to 1, the coefficient of b is equals to negative 4 minus m, and the coefficient of c, in fact, the constant itself is 1. So that's it. These are our values. Now what we are going to do is just input this into our discriminant. So again, we know our discriminant should be equals to 0 because there's only one intersection with the curve. So b squared negative 4 minus m whole squared minus 4 multiplied by a multiplied by c, in fact 1, is equals to 0. So that would be negative 4 multiplied by negative 4 is 16, positive 16, minus 2 multiplied by a, which is negative 4, multiplied by b, which is m, plus b squared, which is m squared, minus 4 is equals to 0. So we are going to get 16 plus 4 2 is 8m plus m squared minus 4. So 16 minus 4 would be 12. So that would become m squared plus 8m plus 12 is equals to 0. I'm going to solve this manually as this is the last question. So 12 as common, 2 6 are 12, 2 3 is 6, and 3 1s are 3. So we have 2 2s are 4, and sorry, 3 2s are 6 and 2. So m squared plus 6m plus 2m plus 12 is equal to 0. M as the common, m plus 6. Again, 2 as the common, m plus 6 is equal to 0. So m plus 2, m plus 6 is equal to 0. And we have two values for our answer. M is equal to -2 or m is equal to -6. And that's our answer. M is equal to -2 or m is equal to -6 is our answer for question 9. And that's it for today. We have completed exercise 2.6 for now. In the next lecture, I'll try to wrap up the whole chapter. So meet you in the next lecture. Thank you.